Okay, in this part we want to go over stream processes, and that's or stream dynamics, and that's the most important part of this chapter. So make sure you go to Canvas and watch the animations that cover this. The stream processes one and stream terrains. I think there's 3 animations. Make sure you watch all those. Also watch the Amazon from headwaters to the Atlantic, the course of the Amazon. It's a pretty fascinating video, and it gives you some idea of how rivers form and how they travel across whole continents. Okay, so let's check out the stream dynamics part of the lecture. And this is, again, it's the bulk of it. I'm just going to go over this quickly because you're going to get much more information from the animations. Basically, what this does is we do 2 things. We erode the landscape, and then we deposit materials. And this is dependent on what we call the stream gradient, the slope of the stream, its base level, which is kind of when it stops erosion, and the discharge, which is the volume, and it's a function of the width and the depth and the velocity of the stream itself. Okay, so keep that in mind. Okay, so the stream gradient is the degree of inclination. Okay, so just remember that. And it has to have enough energy to transport the sediment load. And as long as it's doing that, it's eroding either the base, the bottom of the stream bed, or the sides of the stream bed, or both. As long as it's doing that, it hasn't reached its base level yet. So that's kind of how it works. So here's the steeper the gradient, the faster the velocity, and therefore the more erosional factor there is. Then as we get down, it starts to level off, the erosional facilities get less, and then it'll empty out into the ocean. So eventually this, over thousands and thousands of years, this will erode down and will become just this very, very gentle gradient. And that's kind of what the Nile River is today. So it starts up here in the headwaters, flows down here where it gets much more gentle, then empties out into the ocean. Now the base level is the level below which a stream cannot erode. And normally that is sea level, but you can have local base level that are often dependent on dams, for example, or hard rock, that form reservoirs. So this would be your base level here, where it's just not going to erode anymore. And eventually this will erode down until it reaches that base level, which is not quite sea level, but almost. Okay, this is the Colorado River, which John Wesley Powell back in the 1840s came up with the theory of base level, where he figured out, yeah, at one point in time, the river was up here, and then this is sedimentary rock, so it's very easily erodible. So over time, though, it eroded down to its current state and exposed all this rock strata along the way. Now it flows very calmly, very gently, but it's still eroding, not nearly as much as it was initially, but it still does some. Here's just an overhead view of it. But water is always going to take the path of least resistance. So it's part of stream dynamics is it erodes fastest here, deposits material here, and so if this is easier to erode, then that's where the erosion is going to happen. This is actually Lake Powell up in Arizona-Utah border. And then eventually you get to the ocean, and that is your ultimate base level. Now, dams can upset this, where you stop the flow of the river, you stop its ability to erode, and so the base level becomes the bottom of the reservoir. But you've upset the whole dynamics of the stream by doing this. So the ultimate base level is sea level, but when you add the reservoir, that becomes your local base level. So here's the ultimate, but now you have the local, the top of the dam based on the fact that you have stopped the dynamics of the stream. It's another view of the Colorado. And again, the flow of the stream, the velocity is fastest on the apex of the curve, slowest here. So you're going to erode here and deposit material here. Okay. Then over here, if you can kind of see this, you would erode here, and you can see the depositional material here. Again, that has to do with the velocity of the stream. Okay, so let me stop here, and then we'll get to erosion and deposition in part 4.